Okay, still you can attend right now, but I cannot guarantee, okay, that you will understand. Huh? Check still, okay,
Okay,
what we are
sir.
doing, just get some ideas, okay? Okay, see.
Okay, sir.
So, yeah, we have been talking about acceleration due to gravity. Yeah, I'm talking about this, see. Yesterday's topic was this, I have not completed it. Variation of acceleration due to gravity with depth. This is the topic we are doing, okay? Now, see. I told you we are going to take Earth. Then I told you that on the surface, if I'm talking a point on the surface, then the value of G is very much clear for us. Okay, the value of G is capital G, mass of the Earth divided by radius of the Earth, and then we have to square it. And we get this value as 9.8 meters per second square. Okay, that is quite obvious. So we have got it. Okay. Then, if this is the center of the Earth, I am taking whole mass of the Earth to be ME. So this is the radius of the Earth. You can check. So now see what we are doing. Okay, now we are talking about at a point which is somewhere here. See, let me just remove this for the time being. So we have a point somewhere here. We are here now. That means we have come below the surface. Okay, and this, how much we have come below the surface, we call it depth. Okay, so we have this depth. Uh, Now, I told you yesterday, as we reach this point, what happens is that this mass is still pulled towards the center of the earth because it is attracted to the earth, okay, and is pulled towards the center, and it is accelerated towards the center of the earth, but the whole mass of the earth, let me show you what is whole mass of the earth. Okay, this is the whole mass of the earth, right, which is going to pull you if you are present on the surface. If you're present on the surface, whole mass of the earth is going to pull you to the center. Okay, but if you are here, what is going to happen? You have already left, I told you, you have already left this much amount of mass behind, right? Okay, you have left this much mass behind of the earth, and that much mass is not going to pull you towards the center. Okay, the mass that's going to pull you towards the center will be the mass of this portion here. So we have to be very careful now when we put the formulas for your acceleration due to gravity. Okay, so just check, I'm going to do it right now, and you tell me whether you're clear or not. Okay, so just check. See, so if I'm calculating the acceleration due to gravity at this point at a certain depth, I'm going to call it G prime. The formula will look like this. See, it will look like capital G, mass of this smaller portion, right, that we have, that is m dash, divided by distance between the center of the earth and this point. The distance between the center and this point is definitely not r, right, because this was r, this was r, this is d. So the distance between this point and this one is how much? R minus d. So I'm writing that r minus d, distance squared. Okay, re minus d, let me call it. Okay, so this is what we are going to start with. So let me just write it down again. Dasanba, I'm just trying to answer your question also, okay, because I'm doing from the beginning actually. So G is equal to how much? Capital G, whole mass of the earth, because you're on the surface, divided by distance between you and the earth, that is your radius only right now. So we have got this one. And we also have this G prime now because we have to write M prime, because we have to take the mass of the small portion now, not of the whole portion. This portion I'm showing you again, this is a mass I'm talking about as M dash. M dash is the mass of this portion, okay. Then the distance between the two of the points, right now will be RE minus D, and whole thing square. Now from here we are going to proceed. Okay, I told you to compare. We are again going to compare, right? Which one is large? Is the value of G on the surface is large, or the value on the of G at certain depth is large? That is what we are dealing with right now. Okay, so I have to divide G dash by G, because that's the best way to compare, no? By dividing the things, right? So I'm going to divide G prime by G, but before that I'm going to make some assumptions. See, I'm going to make an assumption that the density of the earth we are going to assume to be constant. Yesterday I told you the density of the earth is not constant. The most dense part of the earth is the core. Let me just show you. This is the most dense part of the core. Then we have this part which is less dense, which we call, I think, mantle. And finally we have the crust, which is very, very less dense. No? So overall density is not same, it changes. But in our derivation we are approximately taking it constant. Okay, now let me just show you how am I going to use density, right? Density definition is very simple. I'm going to write mass by volume should give me density. That means mass can be written as density into volume. Okay, so you know what I'm going to apply this. I'm going to find what is ME, and I'm also going to find what is ME dash. So that is how I'm going to use it, and then we'll proceed. Okay, so just check and tell me if everything is okay or not. Okay, so see, so if I want to write ME, mass of the earth, I have to multiply with density of the earth and volume of the earth. Density of the earth I've already taken to be rho, everywhere constant, so rho. Volume of the earth is 4 by 3 pi radius cube, right? This is the volume of the earth. This is the volume of any spherical shape, right? So that is I'm going to use over here, okay? Okay, now check. What will be the mass of the smaller portion? The mass of the smaller portion, I'm going to write it like this, see. Me dash, the density is again same, right? Because I told you even the smaller portion I'm assuming it to be having constant density for the time being, okay? Not exactly accurate, but it will work out, okay? Then I must multiply with the volume of this smaller sphere. The smaller sphere also has a volume, so I'm going to write it down now, okay? 4 by 3 pi, the radius of this smaller sphere is how much? Re minus d. So I'm writing Re minus d, and I'm going to put here whole thing cube. This is how you are going to write your me dash. So I'm just going to do that, okay? Guys, if it's not so clear, you can ask me now, okay? Dasamba has just joined. Actually, it was his problem, right? Okay. So when I do that, see what am I going to get, okay? I'm going to get small g equals to capital G divided by Re square. Then I'm writing in place of me, right? I'm writing rho 4 by 3 pi Re cube. Now from here I can easily cancel this and, oh, sorry, not everything, only the cube. So only one Re will remain. And my formula for a small g will look like this in terms of density, no mass, okay? In terms of density, see, it's going to look like 4 by 3. I can write a pi, I can write capital G, I can write rho here, right? This, and this I've written. Finally, I have to simply write Re, okay? So this is another formula to calculate your G on the surface. If you don't know the mass, but if you know the density, okay? How will G prime look like? Let me tell you, G prime will look like exactly identical to this, because in place of me, I'm going to put this over here. And when I do that, I can again cancel, see, I can cancel this whole thing square with this cube. So automatically you will see I'm going to get again similar formula to this. I'm going to get 4 by 3 pi capital G. Rho I'm going to get, but this time I'm going to get Re minus D. This is what I'm going to get, okay? So once I get G prime and G, I'm simply going to divide them. No, that was the main part. So I'm going to do that right now. Okay, so let's do that. So when I divide them, it's going to look like this: 4 by 3 pi capital G rho Re minus D, and then divided by 4 by 3 pi again capital G rho, and it's simply Re. Okay, check. So many things are going to cancel. This whole thing will cancel with this. Even the densities, of course. I'm simply going to get Re minus D by Re. So when I solve it, okay, to write like this, I can write Re is divided by Re, no problem, minus D is also divided by Re, because whole thing is divided by Re, no? So I'm writing separately. So when I do that, I'm going to get 1 minus D by Re, okay? So this is what I got here, see. So we got G prime by G is equal to 1 minus D by Re. Again, if I ask you now, what is the values of D that can take place, right? What are the values of D that we can have? Let me just show you, see. We start from the surface. If you are going from here to here, right, this is the depth. Of course, you are going to tell me the depth is less than Re, right? Because we are going only till here. So the depth is less than Re. Even if I go from here to here, right, the depth is still less than Re. Even if I go from here to here, the depth is still less than Re. But if we reach the center, I'm repeating again, if we reach the center, the depth will exactly become equal to Re. I hope you understand. I hope you understand how we are calculating the depth, right? If I go from here to here, depth is less than Re. Yeah, but if I reach somewhere here, right? If I reach somewhere there, the depth is exactly going to be equal to how much? Equal to Re, okay? So what is the lowest value of depth you can have? The lowest value of depth you can have is 0. That means on the surface, okay? And what is the highest value of depth you can have? You can go up to the center. After that, there's no more depth, okay? So you cannot talk about depth after that, okay? It's like you have reached here. Again, I have to measure from here, no? So every time the depth is always greatest value is Re, okay? So if I ask you now in this formula, right, it already looks like 1 minus some smaller number. D by Re is going to be a smaller number, okay? So 1 by something, a smaller number, right? 1 minus 1, not 1 by. 1 minus a smaller number is going to be less than 1. That means my right hand side is less than 1. That's why G prime by G is going to be less than 1. Even the left hand side should be less than 1, okay? As a result, I can directly write the value of acceleration due to gravity at certain depth will be less than the value of acceleration due to gravity on the surface. So what you have proved here is this, say, yesterday what you have proved is, if I'm going from here to here to here, right, if I'm going at high and high and high, right, far from the surface at certain heights, the value of G decreases. Here I'm going to get 9.8, but here I may get 7.8. Just an example, no? I gave you yesterday also. So at certain height, I'm going to get less and less value of G, okay? Today, what I've showed you just now is that if I go from here to here, certain depths, it looks like we're coming closer to the Earth, right? But the amount of mass that's going to pull us towards the center is reducing. Okay. As a result, still the value of G here also again decreases. Okay. So let me just tell you, or let me just ask you, where do you get the highest value or maximum value of G? At certain height, at certain depth, or on the surface? That's the question. First thing, where do you get at the surface, right? Because that's where you get the maximum value of G. If I go above certain height, the value of G decreases. If I go below certain depth, right? That means I go to certain depth, then also I showed you just now that the value of G decreases. Okay. So if you look at this, I can also make some arrangements now. I can write G prime is equal to G 1 minus D by RE. Now check, I'm going to apply in two cases now. Okay, just check. If I write D equal to 0, let's check what do we get. And if I tell you D equal to RE, let's check what do we get. Okay, so see, the meaning is very simple. D equal to 0 means no depth. No depth means we are on the surface. On the surface, check what will happen to this formula. Okay, our formula will be G prime equals to G 1 minus 0 because our depth is 0. So I'm putting that. Okay, divided by RE. Your 0 is 0 divided by R is 0 only. So I'm simply going to get G into 1. So that means G prime equal to G. That means the value on when there's no depth is equal to the value on the surface only. So it's quite obvious we should get 9.8 only. That means we are on the surface. Okay. Okay. So this formula is giving us that. Okay. So it's a very nice formula. It's accurate so far. Finally, I'm going to put D equal to RE, right? That means we are at the center of the earth. When we reach the center of the earth, I'm going to get G prime equals to G, the value 1 minus D is RE, so I'm putting a RE and then again divided by RE, right? This RE and RE are going to get cancelled and I'm going to get here 1. 1 minus 1 is 0, so I'm simply going to get G prime is equal to 0. Just imagine now, because this is going to be 0, 0 into G is also 0, no? So what is the meaning of this? Let me tell you. At the center, the acceleration due to gravity will be 0 because you can understand once we reach the center of the earth, once the object has reached center of the earth, right, there is no mass, okay, from the earth that is going to pull this mass. So there will be no acceleration as well. Okay, it's like the mass has left all the mass of the earth that can pull the mass towards the center of the earth, right? So that's why we are saying that the acceleration due to gravity will also become equal to how much? Equal to 0. Okay, let me also show you a graph and let me tell you what is going on. See, one more thing I need to tell you here is this. See, here if you look, okay, if you look over here directly, your G prime depends of course on depth, but if the depth increases, okay, your G prime will become less and less. You can see that from here because we are subtracting the D, you know. So if D becomes large and large, that means we are having more and more and more depth, your G prime will become less and less and less. Okay, let me show you the variation very quickly, then I think you can we can proceed. So see, look at this graph. Let me tell you, this is X. I'll show you in a while what is X, and let me tell you this is G, or let's say G prime. Okay, X is 0. Let me tell you what is the meaning of this. X is 0 means we are at the center. This X represents distance from the center right now, okay? Distance from center. So if I tell you the distance from the center is this point, that means 0 meters, right? If you are at 0 meters from the center, that means you are at the center, okay? Our graph will start from here. Why it will start from here? Because the value of acceleration due to gravity at the center is 0. Okay, just check at this point. At this point, I'm saying that the distance of the uh, point is RE. That means right now I'm telling you that we are on the surface. Let me tell you what is going on. Give me some time, guys, okay? This is your center. I'm telling you X is the distance between the point and the center. So I've just taken different points. I'm taking a point here. Here the X is 0. I'm taking here X is less than RE because we are inside. Somewhere here X will be equal to RE because we are on the surface. Somewhere here X will be greater than RE. That means we are at some height, no? Okay. So if I ask you, if we look at this graph, going to the right of this graph means going away from the center because X represents distance from the center, okay? So now check how am I drawing it. Yesterday I've drawn this part, see. If you remember, just check, give me 1 minute, guys. This value is 9.8, the value of G, right? And where do we get 9.8? We get at this, at the surface. So this is the point. When the value of x is RE, we are on the surface, and the value of G is 9.8. And after we go away from the surface, at certain height, the value of G I showed you yesterday is going to be curve and decrease like that, okay? But today's graph, okay, that I'm going to show you is between this region, see. This means we are inside the earth. This also means we are inside the earth, right? These all points represent the distance from the center, and that means inside the earth. That means we are talking about still at depth, okay? You will notice we get a graph which looks like this. That means going from the center of the earth till the surface, the acceleration due to gravity is going to rise. But from the surface and going away from the surface, the acceleration due to gravity is going to fall, okay? The rise is linear rise, but the fall is a curved fall. So right now, I'm not going to discuss right now much more than this. Okay, I do not know exactly whether you have understood or not, but I tried to tell you about all these things about the graph. I think little bit sense it might have made. Okay, but don't worry. Yesterday we got a formula for G prime. I'm going to write it today, and I'm going to compare with today's formula. Okay, yesterday we got G prime is equal to, if you remember, G 1 minus twice h by RE. This is the change of acceleration due to gravity with height. Today we got G prime is equal to G times 1 minus depth by RE. We did not get any, what is that? 2 here, okay? We just got simply like that, okay? So now, yesterday I showed you a few more things. I showed you what is the change of acceleration due to gravity. You can find it over here also. I'm not going to show you that right now. It's there in the notes. You can check, okay? But you have to be clear with these two formulas, and that you have proved that your G prime is less than G with depth, and G prime is less than your G even when we talk about certain height. Okay. So now, I think I'm going to proceed. Okay, guys, a little bit is clear at least, like what we did from yesterday and today. Okay, for Latifa it is clear. What about others? Guys, just respond. Okay, I don't want to spend more time here right now. I've already taken so much time. I think I'm going to go to certain numericals right now. Okay, so just check. 3 numericals I'm going to do right now. I'll not do any new topic today, okay? Tomorrow I'll touch a new topic. See, for Latifa is clear, okay? Only one or two response will do, and I can proceed. Let's go to the numericals, guys. One or two response. Anything you want to ask from your side? Yes. Some questions you might have, guys, from your side.
Sir,
Yes.
so if you could explain the graph again, sir, please.
Okay, graph. Okay, graph is a problem. See, okay. Let's be clear with this. Huh? See. Mm-mm-mm. This is our, what is this? Earth. Okay. So this is the center. Okay, check now. Today I'm saying that, yesterday let me tell you what we have done. Here the value of acceleration due to gravity is how much? Exactly 9.8. Somewhere here the value decreases, somewhere here the value decreases much more. Here much more decrease, much faster decrease. Much faster decrease. If I go away and away, right, from the surface, our height is going to increase, yes, more and more height. But the value of G is going to keep on decreasing, and it's going to decrease very rapidly. Very rapidly. Did you understand this point? Because yesterday we have derived the formula for G prime. We got how much? G 1 minus twice h by R, Because of this 2 over here, you can check. Because of this 2 over here, the decrease in G with height, right, will be very fast compared to your depth, okay? Because in depth, you don't get the 2. Okay. So, yesterday I've shown you, this is G value, G prime. And this is your, let's say, height. Okay, yesterday I just showed you this part. This point means any height or zero height. Zero height, right? No height. 0 meters of height means no height. What is the meaning of no height? No height means where are you right now? We are on the surface. Are you clear with this point? Just now. Are you clear with this? Just check.
Yes, sir. Yes, sir.
Because on the right, if I move, it means we're talking more and more height in this graph.
Right.
Okay. Yeah. So now you look at the graph and tell me, what is the value of G when the height is 0? When the height is 0, the value of G is how much?
So 9.8.
9.8. That means somewhere here, right? I cannot start from 0, 0. Okay.
Mm. Okay, sir.
And then I'm telling you, if we go far and far from the earth will pull less and less. So obviously acceleration due to gravity will be very, very less. No, if I keep on going to more and more height, right? So you tell me now, will the values will still be 9.8 or it will reduce now if I go to the right of this graph?
So it will reduce.
And it will reduce like this, say, a curve. Why did I draw a curve? Because the value of G decreases much more rapidly. This is how you show a rapid decrease. This is not a rapid decrease. Let me show you. This is not a rapid decrease. Okay. So the formulas are telling us that the values will be so and so, that the points will be such and so. Is it okay for the time being?
Yes, it's okay, sir.
Okay. Now see, today what we did. Okay, I'm going to shift the whole graph now. Okay, check. I'm shifting the whole graph now. Okay. I'm going to not draw height anymore. I'm going to draw mm, this one. X, and this is G prime. This X now represents distance measured from the center, not from the surface. So if I tell you this point here means X equal to 0, because we are going to start measuring from here. We start measuring from here like that, like that, like that. We'll keep on going. We'll reach the surface. Then we'll again go to certain height like that. No problem. So actually we are starting from here and going from here to the surface. Once we reach the surface, we'll leave the surface and keep on going away and away and away. Okay. Now you all tell me, what happens to the value of acceleration due to gravity here when the x is 0 meters? X is 0 meters, we are at the center. At the center, I told you, right, there cannot be any acceleration due to gravity. That means the value of acceleration due to gravity at the center is going to be 0. So this is our graph, see. And this is the value of your G, right, 9.8. That's why I showed you this is 9.8 on the surface. But on the surface, the value of x should be how much? The value of x on the surface should be equal to how much? Equal to RE, right? Check. On the surface, the value of x, right? Because x starts from center, and when we reach here, we have reached surface. When we reach surface, the value of x will be exactly equal to how much? Exactly equal to RE. That's why the value here is 9.8. That means the value of x must be how much? It is must be equal to RE. All these points here, all these distances here, x, right? These are x greater than RE. We are going away from the surface. And all these distances, right, represents these points. See, these points. That means we are still inside the surface of the earth. That means certain depth, okay? So this represents x less than RE, okay? And if you notice today, I've written G prime equals to G1 minus D by RE. That means if there is some depth, there will be some value of G, but it will be less than your G, right? 9.8. Okay, that is what we have derived just today, no? As I keep on having some more and more depth, I'm going to get less and less G value, okay? So look at this, see. If I'm going on this side, I'm talking about more and more depth, and when I reach here, what happens? The depth becomes 0. But this graph, I've drawn a linear graph. Why? Because you can see over here also, one of the things which I can tell you is that you can see the decrease is going to be with D proportional to D, no? That's why I'm drawing a straight line. I hope you got my point. Did you understand?
Yes, sir.
Okay, with depth, no? In this side, we are having depth. We're entering inside the surface, and the G should decrease to 0. That's why we have this graph. Okay. So guys,
Okay,
is
sir.
it okay? Is it okay for all of you? If it's okay,
Yes,
I
sir.
think
Thank you, sir.
okay. Then I think we are ready to proceed. No, okay. See, okay. Let's do numericals now. Let me do it slowly only. Let's not be in a hurry. Maybe I will have to make it clear. Otherwise, okay. Let me just increase the size. Okay. So see, the question is at. No need to write this in the notes, but let's quickly do it. Okay. At what height from the surface of the Earth will the value of G become 40% from the value at surface of Earth? Take radius of the Earth, they are given equal to how much? 6.4 into 10 to the power 6 meters. Okay, so try to understand. It's a very simple one. I'll draw a diagram. I think everything will be clear. The question is, this is Earth, not a problem. We are talking about certain height, okay, and we are saying that this is point A, let's say this is point B. The question says here the acceleration due to gravity becomes 40%, right? 40% the value of g, that is what they are saying at certain height. Okay, here the value is 9.8, that is your g, but at certain height the value becomes 40% of g. The question is, at what height will the acceleration due to gravity become 40%? That's the question. Are you clear, guys, with the question? At least 40% value, right? So it's going to be less value, no? So this is the question. If you're clear with the question, then only I'll proceed. Okay,
Fine, sir.
fine. Okay, so let me just show you how we are going to solve it. Very simple one, but I'm going to use this formula today. Okay, just check. So see, g prime is obviously how much? 40%. 40% of g. I'm starting like that. I'm writing g prime is equal to 40 by 100. That's how we write percentage of g. So it's like 4 by 10. 4 by 10 is like 2 by 5. So I'm writing 2 by 5 g. Okay. So this is the relation between g prime and g. Or I can also tell you g prime by g is equal to 2 by 5. So if you remember, this is how we can write. Okay. From here only we can write. So g prime by g is 2 by 5. Okay. Now I'm not using the approximate formula, but I'm using the other formula. Just check how much we are going to get. Okay. So see, I'm writing like this: g prime by g is equal to, if you remember, it is equal to re square divided by re plus h whole thing square. If you remember, we have this formula also just before we have finished the derivation. Okay, you can obviously also use this one. Okay, the one which you got, 1 minus twice h by re. Okay, you can try this also and try to see how much close you're going to get, but this is going to give you very accurate. If you remember, this is we have obtained from approximate formulas. We have omitted higher powers of h by re, if you remember, right? Square and powers of 3 and so on, we have omitted. So this is an approximate formula, but anyways, you're still going to get it. Okay, but let's say I'm going to use this. If you remember, we have got this formula also. Okay, so when I use this, I'm simply going to write, in place of this, I'm going to write 2 by 5 because of 40% thing, right? I'm getting like that, and then on this side I'm getting re by re plus h. Let me just do that, and whole thing square, and then I can arrange the terms. Okay, when I arrange the terms, I'm just doing it directly right now. You please check the steps in the notes. Okay, I'm writing re plus h will be equal to root 5 by root 2, and then I'm going to get here re. This is what we are going to get. I'm not worried about the steps right now. I can give you the steps later. Okay, when I do this, okay, I just need to solve it, and I'm going to get the value of h equals to 3.72 into 10 to the power 6 meters. I'm simply going to put the value of re. That's it. Okay, you can also try using this because I know you're familiar with this. Okay, but I've done in this way, so please check. Okay, I think this was not a problem. I think you've understood what I did here just now. Guys, is it okay? I'm not worried about the steps. Okay, but you just need to understand what is going on. That's it. Steps you can learn later. Okay, guys, can I proceed? Mm,
Yes, sir.
Shelby is okay. What about others? Dasanba is here. Dasanba can also talk. Sanu has said okay. I think it was Sanu. Then Jonavan is also there. Desmond, not Desmond. Esmond. Latifa, is it okay? Did I make it complicated, or is it fine?
Sir,
Latifa,
it's fine.
fine. No. What about Arman Ki? Arman Ki is also here.
Yes, sir.
Okay. That is fine. Then I can proceed. Okay. Let me go to the next problem here now. Question number 3 in your notes. At what height? Question is, at what height from surface of Earth will the value of G be reduced by 36%? Okay, they've said again, take radius of the Earth to be 6,400 kilometers. Okay, now this is a bit different. You can already understand why it's different. The question does not say that the G has become 40%. Okay, let's say it is not equal to 36% of G. This is wrong. The question says the value of G has been reduced by. this much amount. That means now you tell me, okay, what is the value of G? If you can tell me, what is the value of G? I'm waiting for that. What will be the value of G prime? Sorry, not G, but G prime. Is it going to be 36% of G, or it is going to be how much? G prime. Is it going to be G or less than G? First tell me that. It is reduced, right? It's reduced by
Less than G, sir.
less than G, but how much? What do you think? If the value of G is reduced by 36%, that means the new value of G should be how much? 64% of G. Do you agree with this? Okay, or let me just say like this. I'm saying G becomes 64% of G value, G prime, at certain height. Indirectly, I can tell you the value of G has reduced by how much percent? The value of G has reduced by how much percent? You can tell me now by looking at this. Everything of G is called 100%, right? All of G is called 100%. 64% of G means what? 64% of G means the value of G has reduced by how much? 36%. Did I make it clear? I think you understood the way I said, but still I'm waiting. Are you clear with this?
Yes, sir.
Okay, okay. What about others? Others speaking, please guys, just respond or I'll proceed.
Yes, sir.
Okay. So see, I'm going to use the same method now. I'm going to write G prime is equal to 64%. That means 64 by 100 into G. I'm going to write G prime by G equals to 64 by 100. And you know again, right? I can write here RE square by RE plus H whole thing square. Again, I just have to find at what height the value will be reduced by 36%. Okay, so again, I don't need to show you the steps and all. Please check in the notes the steps and you are going to do the calculation. Okay, if you have not collected the notes, I'll send you the picture again. Okay, plus please remember we have done it like that, huh? Okay, I will show you one more and check. This is on the depth question. Okay, so just check. This is question number 4. How much below? How much below? Please do the questions from your school also. Okay, please you can share to me whatever questions they are doing. Okay. I will also try to do NCRT problems after I'm done with the chapter. Please remind me, okay? Sometimes I'm skipping NCRT questions and all. So you have to tell me, huh? To do this, to do this, and to do that. Okay? So you have to do that. Okay, check. How much below the surface of the Earth does the acceleration due to gravity becomes 70% of its value? It is not saying reduced by 70%. Okay, it is just saying it becomes this much value, 70% of the value of on the surface of Earth. Okay, on the surface of Earth. Okay, so check. It's the same type of question, but this time we are not on the surface. On the surface, we have a value called G. Somewhere here at certain depth, right? They have said the value of G prime, the new G becomes 70%, right? It becomes 70% of the value of G. Okay, I'm simply going to write G prime is equal to 70% of G. Then G prime is equal to 70 means 70 divided by 100 of G. 7 by 10 I can call it. So G prime by G is equal to how much? 7 by 10. Today we got a formula, if you remember, that is your 1 minus D by RE. So this is what I've shown you in the notes. Okay, you simply have to calculate at what depth. So this is the equation for us. See, I have to calculate what is the depth. At what depth the value of the G will reduce by 70%. Okay, and the answer you can check. Okay, we are going to get some values. So I'm not showing you much more than this. That's why see. Okay, I'm doing the numericals very fast because I'm taking time on derivations. No, once you understand the formulas in your derivations, I think it's going to become very easy. Okay, and of course you have to remember the formulas. No, I think guys, is it okay for this topic right now? Is it okay? If you say it's okay, then I'll proceed to the next one. If you're okay with whatever I've done just now.
Yes, sir.
Okay. Is it okay if I do the numericals like this without showing you all the steps? I think you can follow, no? I think so.
Yes, it's fine, sir.
Fiona, what does Fiona has to say? Fiona? Fiona is getting angry, I think. Fiona. Donna is also here. Fiona doesn't want to talk. Okay, I will proceed. Okay. If you have doubts, please stop me, huh? Okay, now see. Two questions I'm quickly going to ask you. You are going to think and answer me, okay? See. By now, I think you know, right? Earth's shape is not spherical, it is oval. Okay, so I'm just changing the shape. See. This is the equator, we call it. And these are the poles. North pole, you know, this is South pole. This is the center somewhere here, okay? Center. Okay. Now you guys tell me, okay? Is the radius measured along the poles and the radius measured along the equator for the Earth, is it equal or not equal? That's the first thing. Oval shape, okay? I'm trying my best to draw oval. See, it's like that. But not like this, okay? Of course. I'll just extend it, no? So this is the equator, right? And this is the poles, right? So where do you get more radius? Tell me, along the poles or along the equator? Where do you get more radius of the Earth?
Equator, sir.
Along the equator, yes. This radius along the equator is large, yes. And along the poles, the radius is small, okay? Now my question is this. Poles, okay? Where do we get larger value? G value at the equator or G value at the poles? That's the question. Which one is large? That's the question, okay? Where do you get more value of G? At the poles or at the equator? Somewhere here or somewhere here. At the poles you get more value or you get at the equator. If it was, let me tell you, if it was same, right? Then your RE is same and you get same values. No, but right now I showed you already that RE is less if you're measuring along the poles. And your RE is large if you're measuring along the equator. Let me show you the formula for G again. On the surface, the formula is how much? Capital G, mass of the Earth, divided by radius of the Earth squared. If I ask you the value of G at the poles, you have to write G at the poles, and I have to write radius of the Earth, but along the poles. And if I want to write what is the value of G on the equator, I have to write capital G, mass of the Earth, no problem with that, radius of the Earth square, but along the equator. Now looking at these two formula, you just told me just now, radius along the equator is large. This RE is large. That means this is large and this is small. So you check and tell me, okay, number one or number two? This is number one and number two. In which formula are you dividing by a larger number? For the poles or for the equator? That's the question. In which formula? The number one formula or number two formula? Yes, one or two. You're dividing by a larger number. Number one or number two?
Equator. Number 2.
Equator, number two, yes. In number two, you're dividing by a larger radius, okay? As a result, when you divide by a larger radius, the acceleration due to gravity at the equator will be less, little less, let's say, compared to your acceleration due to gravity at the poles. That's why always remember acceleration due to gravity at the poles is more compared to acceleration due to gravity on equator. Okay, so I hope you understand. I've made it clear. I hope so. But if you guys did not understand, I can speak again. Okay, but are you clear, guys? Let me just ask you. You can understand why, right? Yeah, because at the poles we get more gravity. Why? Because we are much closer to the center of the Earth. And along the equator, we are very far from the center of the Earth. As a result, we face a little bit or let's say less acceleration due to gravity. Okay, so that's why poles we are very close to the center of the Earth. Not very close, but somewhat closer than your equator if you are at the equator. Okay, I think this part is clear, right? Guys, if it's okay, then I think I can proceed. I'll just start to you. What is the next topic? If you're okay, then I will proceed, guys. Okay, so it's up to you. Just respond, one or two students. If anybody has doubts, you can stop me on this. So Lilu is clear about this. What about Sanu? Sanu is clear, no? I think, yeah, Sanu is clear. Sleepy Frank. Sleepy's Frank never talks. Sleepy Frank is always sleepy. Sleepy, tell me.
Yes, sir.
Okay. So Sleepy Frank is also there. He's not sleepy. Okay. Okay, I'll just introduce you this new topic. I'm tired there. I don't know what to do. Else to do. Tomorrow also we can do this topic. Let's take tomorrow, no? Many students are absent today. One day, 2 day. Let me just check how many days I'll take. 1 day, 2 days, 2 days, 2 days. Numericals, please remind me in the group. So I have to send you 2 days. I think I can finish in another 2 days. I have to do that. 3 days, 3 days. I think this week will take again. Okay, this chapter will take another week. Another week means this week, of course. So guys, I just want to stop today. Okay, I took a very short class today, but I think it's fine. No, whatever we did. I don't know. I did not do much only. I just did only the depth part and the graph. Okay, it's okay for today. It's okay, guys. Okay, I just want to stop for today. How guys? Okay, guys. You also take rest and then anything you want to ask, you can ask. Otherwise, I will sleep. You also sleep. Okay. Can I say bye, guys? Is it okay?
Okay, sir.
Bye.
Thank you, sir.
Bye.
Thank you, sir.